Okay, we have one more thing to learn about gas laws, and that is the ideal gas law. And the ideal gas law takes all of the different parameters we can measure about a gas, and there's an equation for it. So if we know 3 things about the gas, we can figure out the last thing. The formula looks like this. PV equals nRT. So of course, P is pressure, V is volume, N tells us how much gas we have, and that's number of moles. T is temperature in Kelvin, and R is a constant, which means it's always the same number. A scientist determined back in the 1800s that any sample of gas he worked with, if he took the pressure times the volume and he divided it by the number of moles times the temperature, he always got the same number, no matter what, which is pretty cool. This sim number here, that is R, our gas constant. And the number is 0.0821. So we can use this equation right here to solve for something as long as we know the other 3 things in a sample of gas. So I'm going to do an example problem. The problem reads like this. An unknown quantity of gas occupies 12 liters at 0.95 atmospheres and 310 Kelvin. How many moles of gas are present? So our formula is this, but we can use some algebra to rearrange this to solve for moles, which is this one. So when we rearrange that equation, the number of moles is equal to PV, and this is multiplied together, divided by RT. So you would multiply these 2 things together, and on the bottom, these 2 things together. So an example one, right here with these numbers, so we're going to put these numbers in. So the pressure is going to be this. It doesn't say pressure, but atmospheres is a unit for pressure. That's how we know it's pressure. So we'll put 0.95. I didn't mean to put parentheses there. 0.95 times, and then volume. Well, liters is volume. So 0.95 times 12. That's going to go on the top. I'm going to rewrite that whole thing. Actually, we'll just write it down here. So 0.95 times 12 liters divided by R is that number that we had earlier right here, that constant. So every time you see R, we're going to put 0.0821 times temperature, and our temperature is 310 Kelvin. So we just put this in our calculator, 0.95 times 12 divided by 0.0821 times 310, and we get 0.448, and we were solving for moles. So this is moles. Now we can also use this formula to solve for other things. So on your practice worksheet you have today, I rearranged that for you. And I even put the formulas on the board. So for example, if you were solving for volume, if you rearrange this formula for volume, it equals nRT divided by P. So I've written on the board all the formulas that you would need depending on what you were solving for.